Welcome back to the vlog. I hope you're doing well. It's Friday the 18th and I decided to record today because I'm going to visit the job that I did a video on 2 weeks ago. No, it's longer than that. It's getting on for 4 weeks ago now. The electric boiler one that had huge electric bills. So we've completed the system and I'm going up today to do a final sign off. The lads on site do a pre-commission, so they'll do a function check and make sure the whole job's working as it should. But I go to do a final sign-off, hand over MCS documentation and answer any questions the customers got. So that's my job this morning. I need to get my hair cut and beard trimmed. It's been busy the last few weeks, to say the least. For you guys out there that are MCS registered, carrying out MCS installs, you know how hard it is, and as I've said before, we're doing 10 sign-offs a week, so it's challenging and it ages you. So, but we're lucky because all the guys in the office are awesome. You know, Dave, Rosie, and all their teams keep this ship moving. But it's challenging at times, but rewarding. And this is the bit about my job I love: going out and commissioning the systems and having happy customers. We don't get it right first time every time, and anyone that says they do are lying. Everybody has leaks, everyone has issues. It's the way you deal with the issues that's the important factor. But at the end of the day, when I turn up at people's houses, the warmer and their energy bills are where they want them to be. That's all that matters to me. We're not a company that goes about showcasing top of the scops or anything like that. It's about getting the correct run costs that the customers have been estimated and they're happy with, comfort, and a system that will last for years. And I am going to mention that in this video today, about how we go about that with what I call correct system volumes. There's a lot online at the moment. There's a lot of drama about buffer tank or no buffer tank, volumizer or no volumizer, low loss headers, as if it's all some new idea. The heating industry has had those products, those engineering solutions for decades and decades, and we've used them in the heating industry for decades, and they're all good. They're there when you need them, and if you don't need them, you don't need them. We all know that a simple system is a reliable system. Stripping it back and having it as simple as possible, as direct as possible, of course, is the most efficient way to do it. But when we're talking heat pumps, as opposed to gas boilers or oil boilers, there's considerations we need to make. We've got to be super careful to protect that plant and equipment, that it's going to serve that customer for years and years. It's like finely tuning a car. If you tune a car to within an inch of its life to get the best fuel efficiency, it might not last as long. Again, if you tune a car to have high performance, it'll run out, you know, it'll break down a lot more. You've got to have a robust system. So it's using those bits of equipment where necessary. If you need a volumizer, you need one. If you need a buffer tank, you need hydraulic separation because the distribution pipe work might not be big enough, then use it. That's absolutely fine. Nothing's off the table as far as I'm concerned. There's no argument to be had. The correct piece of equipment in the correct application is all good. So if you've got a buffer tank and you need it, super duper. If you've got a volumizer and you need it, excellent. If you can design out both of those bits of equipment, fantastic. This unit I'm going to, it's pipe direct, and what we mean by direct, we're using the heat exchanger pump in the unit to pump all of the water around the system. There's no secondary pump after a buffer tank. So we're just going straight from the heat pump to a diverter valve and off to the radiator system. This job, we've been able to do it because we can come off that 3-port diverter valve and split 2 ways. You know, we're splitting our heat distribution 2 ways immediately. And our index circuit in our biggest room, so our greatest heat loss room, has got 2 radiators in, so we're almost splitting it across that room. Therefore, the index circuit doesn't have a massive pressure loss. So we've managed to do it direct with the pump in the heat pump. However, we've got a volumizer on the return, and the system volume is essential in a heat pump. When you look at a manufacturer's literature, a lot of them will state a minimum system volume. And a minimum system volume is just that, the bare minimum. If you're a high-end installer, you should be installing the correct system volume. And what we mean by that is we're working out what our lowest heat pump output is and the warmest operating design temperature. So if somebody's going to use their central heating when it's 15 degrees outside, their heat loss on the house might be very low. And if that is below the minimum operating output of that heat pump, you've got a risk of cycling. Therefore, you've got to guarantee a correct system volume. So we do a formula for that, where we work out that minimum output, minimum demand, and the minimum starts and stops per hour we want. I don't want any of my heat pumps starting more than 3 times an hour, okay? Most of the time, they will not start more than once or twice a day. They'll come on for heating and they'll modulate all day, and I won't have any starts and stops. Like I say, worst case scenario, 3 times an hour. So this unit we're going to today has about 8.5 kilowatt output and a minimum output of 3 to 3.5 kilowatts, depending on a few different factors. Because if you drift your delta T, you can reduce that output, but that's getting a bit too technical. So when I've done my calculation, my correct system volume is 180 litres. And a lot of installers might be like, really? But when you work it out, stop cycling in warm conditions, that's what I need. Now, I'm lucky that this job we're going to, we've got a load of K3 radiators, we've got a load of big pipe work, and we've got a hell of a lot of system volume already. So I've just had to put a 50 litre buffer, not buffer tank, 50 litre volumizer. The reason why I say buffer is because it is a 4-pipe buffer tank, but I pipe them just with 2 ports as a volumizer, and I put it on the return from the system. So it's direct, there's no distortion, there's no loss of efficiency. You could argue there's a bit of loss of efficiency from the having that extra system volume stored, but a well-insulated buffer tank in a plant room, it's the square root of nothing. So yeah, I find it quite surprising when installers say, oh, I rarely need a volumizer, I rarely need a buffer tank. I'd say it's the other way around. More often than not, you need a volumizer for the correct system volume. If somebody quotes minimum system volume from a manufacturer, they've not worked out the correct system volume. And the reason why I do it is because I want my heat pumps to last well over 10 years. I want them to last 15 years plus. And we've got units out there at the moment that I've revisited recently. We service them every year that are exceeding 15 years now. Our oldest is 18 years old and still going strong. And I truly believe the only way we've achieved that is with the correct system volume. So anyway, I'm going to go along to the site now, and I'll give you a quick overview of the house from outside. I'll show you the heat pump, I'll show you the plant room, and I'll talk about it a bit. The customer's sound as a pound. We've done a hell of a lot of work there. It's been a challenging job, but the lads have done a storming job. They've got it in really nice and neat, minimum disruption. Customer's happy, but the customer doesn't want us inside the house filming, which is, I totally understand that, 100% respect for that. But we're going to film outside, we're going to show you the property, pan around the property, and show you the heat pump and the cylinder itself. So, cheers. Hello, I am back at the install. You may have seen the video a few weeks ago on the electric boiler, so I thought I'd do a revisited. I've just commissioned it now. So we are in a sleepy village in Lancashire, absolutely beautiful. I'll just show you the outlook. And the house itself, the house in question, is this place. It's a lovely detached country style house. And if you remember from the original video, it had an electric boiler, well, actually had 2 electric boilers, so it was costing the customer a fortune. If you notice on the roof, we've put solar panels. We've also done internal wall insulation. So most of the external walls in the property, the bedrooms, the lounge, we couldn't do the kitchen obviously because of the units, but the majority of it has had internal wall insulation. And we have installed a heat pump. So I thought I would show you exactly where we've got to with it. So I'll take you into the plant room and the heat pump itself, and yeah, show you what it's all about. So this is the heat pump behind me. It's a 8.5 kilowatt output unit. It's currently running in central heating. You'll see the fan moving there, and you'll probably be able to just about hear it. It went in quite well. It was a tight spot, as you can see, but it lended itself to it, this location, because it's got a big back garden for it to expel its cold air, and we've put the cylinder in the garage behind me. So I will show you the heat pump itself. 8.5 kilowatt global energy unit. We always put a full condensate base beneath it, because even though you've got your condensate plugs below the tray, in really extreme weather, which we do get in this area, icicles and whatnot can form around the evaporator, and when they can run off the edge. So I like to encapsulate the whole of the bottom of the unit, because we do not want slip hazards forming around the unit itself. The plant room, as I said, is directly behind in the garage, so I'll just nip in there and show you what's going on. So again, if you remember the video with the electric boilers, they were on the wall here. So we've replaced it with this 300. It's a 300 litre domestic hot water cylinder, because there is 2 bathrooms, and the occupancy in this house can be large at certain times of year, and they're quite high users of hot water. We've piped this direct, so it's not hydraulically separated at all, as in there's no 4-pipe buffer. It's a single pump from using the heat pump's heat exchanger pump, doing all the pumping in this place. So from the Belimo valve behind me here, we've gone straight from that off to the central heating system. We were lucky that we could split straight away, so we can split from the 28 to 22 in 2 directions. So our index circuit is our furthest radiator in the lounge, but again, that lounge has 2 radiators in, which is obviously halving the heat distribution there. Therefore, we could get away with just using the heat exchanger pump in the unit. And again, we have put a volumizer on the bottom. I know you might not, I'm not an expert with this camera yet, but ultimately what we've got at the bottom is a 50 litre volumizer. Now, just so you know, it is absolutely critical with heat pumps to have the correct system volume. Now, a lot of people at the moment say things like minimum system volume. When a manufacturer states minimum system volume, what they're referring to is the amount of water, the amount of energy that's required for a defrost cycle. The correct system volume, which is a calculation that an engineer should do, is to prevent cycling. So when we install a heat pump like this, which is 8.5 kilowatts output, it can modulate down to about 3.5 kilowatts output. If the demand on the house drops below that and the radiators aren't dissipating that minimum output, what can happen is the heat pump can cycle on and off unless you have a substantial system volume. Now, a lot of manufacturers will say, generally on a unit this size, 40 litres minimum system volume, 50 litres minimum system volume, but the correct system volume on this site is 180 litres. That's what we need to guarantee that we won't have cycling in warmer weathers. So that's why we've stuck that 50 litre buffer on. We've got a shed load of K3 radiators, a lot of big pipe work that has a lot of volume. Incorporating this 50 litre buffer tank, well, not buffer tank, volumizer, because it's piped through on the return, we've got that correct system volume. So I've got confidence this unit's going to serve this property for years to come, and that's the key. It's all right having a minimum system volume of 40 litres for your defrost, but if you're having lots of starts and stops on your compressor, you're shortening the life of it. And as far as I'm concerned, if you're going to the expense of having a heat pump installed, you want it to last for 15 years plus. If it's just going to make the manufacturer's warranty of 5, 7 years, whatever it is, and then die on you in 10 years' time, that's no good. It must serve you for many years. And correct system volume is what it's all about. If somebody says minimum system volume, ask them what the correct system volume is, and there's a formula to do to achieve that. So again, just on this site here, it is in central heating mode, and I just thought I'd walk around the heat pump so you can hear exactly how loud it is. We're lucky enough to get the pipe work straight through the back, straight through the wall, in some good quality insulation there, so we're minimising heat loss. But I don't think that's too offensive, that sound. Right, so I just want to finish this video with a final summary of that installation and the whole process and what it's all about, because obviously we couldn't talk to the customer about it. So I just want to give you a full run through of what we quoted for and what we've done. So customer was on electric boilers, 2 electric boilers on a wet system. They had plastic microbore pipe. We did the full heat loss survey. Basically we couldn't get the heat through that 10mm microbore pipe, and we couldn't deliver it at the delta T we wanted to do at that temperature difference. The pressure loss would have been far too great. We could have put a buffer tank on it in a 4-pipe arrangement and put a honking big distribution pump on to overcome the pressure loss, but it would have just been, it would have meant we'd had poor system efficiency. So the decision was made to repipe the whole house essentially, and do it direct as I've described in the video, just using the one pump built into the heat pump. So it was a full repipe, all new radiators. There was 1, 2, 3, 4 K3 radiators downstairs, 2 in the lounge, 1 in the kitchen, a K2 in the kitchen as well. The hallway, porch, rear porch, they all had K2 radiators in, and all the bedrooms were K2s. They didn't look ridiculously big. All designed at 40 degrees flow temp, mean water temp at design conditions, which I think that area is about -3. So that was that. 8.5 kilowatt unit, 300 litre domestic hot water storage, because we wanted to make sure that when their house is fully occupied they had enough hot water for a full capacity house. Solar panels, 4 kilowatts of solar, and then internal wall insulation was installed by a third-party company. So yeah, it's made for a really good system. Like I said on the previous video when I was on the site survey and I was showing the electric boilers, that no matter what I did on this job with this heat pump, I would save them money against their existing system, because the electric boilers was a kilowatt in, kilowatt out, and even if I did a really poor system, a really poor install, and got a stop of 3, so every kilowatt out, every kilowatt in, 3 kilowatts out, I'd save them money. So they were always onto a winner with it from that point of view, but obviously we've aimed to get as efficient system as possible, and it should get a SCOP of over 4. I'm quite confident about that. On heating will be well over 4. So yeah, really positive result. I'm looking forward to revisiting that job in 12 months time for its annual service, and see how they've got on. The customer is super keen on keeping an eye on the energy costs. He's already been keeping an Excel spreadsheet with the day-by-day running costs. But the beauty of the global energy heat pump is it's got the onboard monitoring, and it's recording the MID, so the electric meter that's MID approved. It's recording the pulses from that every day, and that gets uploaded to the portal, so they can see their day-by-day energy costs, which is cool. So they've got full visual on what it is costing them day by day. Yeah, so really good job, really happy with it. I'm sorry I couldn't show you inside the house, but I wouldn't want somebody filming in my house. So yeah, 100% respect to the customer for that. And I appreciate them letting me film outside and the outside of the house. So yeah, I'm on my way home now, picking up the Chinese. It's Friday night. Hopefully I'll get this hair cut and I'll look a bit more presentable next week. If there's anything that you guys want me to discuss and give my opinion on, I'm happy to do that. I'm happy to do a video about that. Like I say, all the opinions I give are mine, Adam Rowlandson, as an installer. It's my opinion. Any of the branding that I'm associated with, it's just my opinion. So, and yeah, I'm up for doing a video on anything. Like I say, I'm no expert, and as I've said in previous videos, I've got experience. I've been doing heat pumps for 18 years. I've been in the heating game for 24 years. That's frightening. God, 24 years in the heating game. And I know what I know. and I don't know it all, and I've learned a hell of a lot over the last 10 years from all the engineers I've worked with. And then more recently, as I've said on the other videos, the beauty of the social media side and the your LinkedIn and your Facebook groups is we've got experts in different fields. We've got the hydronics experts, we've got the refrigeration experts, the electrical engineers, and we're all coming together and making our heating systems better. So yeah, like I say, Friday night, I'm going to knock it on the head. We'll see you all next week.